Okay, so let me just read the notes here. This is page 7. It says, recall that for a graph to be considered a function, it must pass the vertical line test. Right, so that means a graph that looks like this would not be a function because it wouldn't pass a vertical line test. That means if there's a vertical line that I can draw where it touches more than one point on the graph, it's no longer a function. So we can tell that here, this is a function because no matter where I draw up a vertical line, I'm never going to touch more than one point on the graph. Okay. Now, for a function to be an inverse, it must pass the horizontal line test. So what that means is this would have an inverse that's a function because it passes the horizontal line test. So what that means is if I were to, basically an inverse is a graph that is flipped sideways. So you can imagine that this flipped sideways would be a function. So something that passes the horizontal line test would be able to pass the vertical line test for its inverse. Okay. So now this graph here, this is a function, but this graph does not pass the horizontal line test. So if we were to graph this horizontal, at its inverse, it wouldn't pass the vertical line test. Okay, so that's what the horizontal line test means. It means that if you switch the x and y's, the inverse would then pass the vertical line test. So the horizontal line test tests the vertical line test of the inverse. So here are the properties of the inverse function. If I were to switch the x and y, that means the domain and the range would also switch. Okay. And an inverse function is one where you can imagine it folding over the line y equals x. Okay. So a graph like this here. These two graphs would be inverses of each other because if you were to fold the graph over the dotted line, y equals x, you can imagine the graph overlapping. Okay, so we said that this is not going to be an inverse function because it doesn't pass the horizontal line test. So this graph is a function, but the inverse is not. So, but what we can do is, what if we only produce, or what if we only show a portion of this graph? So basically, what if we restrict the domain? If we restrict the domain where we're only doing a portion of the graph, then we can make it a quote unquote function because it would pass the vertical line test. So that's what we mean by restricting the domain. We're only letting a portion of the graph be the function so that when we flip it, it will actually turn into a function. Okay. So if it says, if we restrict the domain of the sine graph from negative pi over 2 to pi over 2, then the restricted portion would pass the horizontal line test. Therefore, the inverse would be a function. Okay, so right now we don't have to worry about what the graph looks like. We just have to understand that this is leading to a couple of rules that we have to keep in mind. Okay, so we refer to these restricted values of x as something called principal values of sine. Right. So notations for inverses is uppercase inverse sine or arc sine. Inverse sine and arc sine are they're interchangeable, but this uppercase S and uppercase A means we're talking about principal values, which I'm going to talk about a little bit later. Okay, uppercase cosine, inverse, arc cosine, these are the same. And then uppercase tangent, arc tangent, they are interchangeable as well. Okay, the capital letters at the beginning, they indicate you're finding principal values. And here's how the domain restrictions will look with respect to the unit circle. So if we're trying to find inverse sine, arc sine, we're only going to restrict ourselves to values between the fourth and the first quadrant. So sine is only going to be restricted to this. Okay. For cosine, it will be restricted to the first and second quadrant. So if we're ever asked about inverse cosine of any value, we're always looking for measures that land in the first and second quadrant. And then finally, for tangent, tangent is the same thing as inverse sine. We're looking for values in the first and fourth quadrant. Now, quadrant 4, however, we have to be careful with quadrant 4. Quadrant 4, I know we're typically used to, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6. But with principal values, we have to make the adjustment that these are negative values leading into 0, into a continuous point 2 pi over 2. So for sine and for tangent, we have to realize that 3 pi over 2 is really negative pi over 2. We have to think of 5 pi over 3 as negative pi over 3. We have to think of 7 pi over 4 as negative pi over 4. And we have to adjust to the fact that something that we normally think of as 11 pi over 6 is really negative pi over 6. Okay, so those are the adjustments that we have to make, and I'll refer back to this as we go through our examples. Okay, so again, inverse sine and arc tangent are going to be first and fourth, and then cosine is going to be first and second. Okay, this will ensure that any values that we're looking for is because this is, well, the reason why is because sine is going to be positive in the first quadrant, negative in the fourth quadrant. So there's a nice continuity of all the positive and negative values accounted for between these two quadrants. Cosine is positive in the first and negative in the second quadrant, and that way we will be able to ensure that all the values we're looking for, the spectrum of all the values we're looking for, is covered in these two regions. And then tangent is positive in the first, negative in the fourth, and so these two regions will ensure all the positive and negative spectrum of values that are covered. Okay, so the reason why tangent is not first and fourth is because tangent is positive first and fourth quadrant, so we're not able to get the full spectrum of values. So first and second. Okay. All right. Example 1. Okay, so the way we say this is find the arc sine of negative 1/2. So in other words, this is saying when is sine of theta equal to negative 1/2? So a way to kind of think of this in something that we recognize, this is basically saying when is sine of theta equal to negative 1/2. So we're looking for the angle measure where this is true. Now, you know that sine is restricted to the first and fourth quadrant. So where do you see the sine value being negative 1/2? Well, but yes, it is quadrant 2, but remember with inverse, with principal values, we have to restrict ourselves to the first and fourth quadrant. Okay, so do you see negative 1/2 for sine? There we go, right? But we have to make an adjustment, right? It's not 11 pi over 6, what do we call it? Negative pi over 6. Yeah. Okay, so we're kind of have to work a little bit backwards in that sense, but really we're just kind of understanding that we have to look at unit circle a little differently, but we're still basically dealing with a unit circle. Right? So theta is equal to negative pi over 6. Basically, yeah. What angle has sine of theta equal to negative 1/2? Right. So hopefully you guys don't feel like you're doing anything new. You're just looking at something that you already know from a different perspective. Okay. Example 2, find inverse tangent of 0. So in other words, it's asking when is tangent of theta equal to 0? Okay, so tangent, again, we're restricting ourselves to just the first and fourth quadrant. Where do you see tangent equal to 0? Yeah, but we don't say 2 pi, we're going to say 0. But yeah, you're right. We're looking at this location, right? Tangent is y over x, 0 over 1. We're going to go from the full spectrum from negative pi over 2 all the way to pi over 2, and it's going to pass 0 along the way. Yeah, good. So theta is equal to 0. All right. let's look at part A. When is arc sine? We want to find the arc sine of -1. So in other words, when is sine of theta equal to -1? Okay, so remember sine, first and fourth quadrant, right? Okay, where is sine equal to -1? Good, right? We see that location. We have to make a slight adjustment. We can't call it 3 pi over 2. Principal values, we have to make adjustment in the fourth quadrant, -pi over 2. Our cosine -√2/2. In other words, when is cosine theta equal to -√2/2? Now, cosine, which quadrants do we look at? Good, 1 and 2. So we look at 1 and 2, cover up the bottom. Okay, where is cosine equal to -√2/2? Good. Now, once you're in the second quadrant, you're fine. You can use whatever you see here. It's just the fourth quadrant. We have to make a slight adjustment. The first and second quadrant are exactly as you see it. Yeah. There we go. 3 pi over 4. Okay. Tangent. When is tangent equal to 1? First and fourth. Where do you see tangent equal to 1? Good. Right, pi over 4. Y over x, we know it can't be here. This is negative. Okay, can you guys try D through H? Sorry, D through I, and I will follow up after you guys give it a try. Okay. Is anyone confused, or is this making sense? Yes, okay, yeah. Can I do which one? C. Got it. Okay, so this is so when we say arctan equal to arctangent of 1, we're asking ourselves, when is tangent of theta equal to 1? So tangent of theta equal to 1 means when is sine over cosine equal to 1? So where do you see y and x being the same value where we're going to be able to get 1 in return? It's got to be pi over 4, right? Because that's the only time we're going to get 1 is so the numerator and denominator have the same value where everything cancels out except 1. Yes, question? Yes, however, remember with tangents, we're restricting our domain to the first and fourth quadrant. So yes, there's always going to be duplicate, so that's why there's a restriction. For sine, it's only first and fourth quadrant. Cosine is only first and second, and tangent is only first and fourth. We're restricting the domain because we want the inverse to be a function, so we're forcing it so that if we were to flip it, it will still pass the vertical line test, so that there's no duplicate values that's going to cause an issue with our function. Good. Any other questions before you guys try some of these? Okay, give you guys a few minutes and I'll go over each of these as well. If it helps, you can rewrite all of them as, sine of theta equals 0, cosine of theta equals √2, just to get it into a form that you recognize, and then just understand that you're just trying to find the angle measure where this specific ratio is occurring. Okay. Part D, when is sine equal to 0? Yeah. Part E, when is cosine equal to √3/2? Yeah. Part F, when is tangent equal to -√3/3? Now, this is in rationalized form, so this is the same thing as -1/√3. Maybe that's easier to pick it out. Where's tangent equal to -1/√3? Good. Yeah. So see that -1/√3. That's the same thing as -√3/3. In the fourth quadrant, we make a slight adjustment. It's not 11⁵/6. It's going to be -π/6. Okay. Where's sine equal to √2/2? First quadrant. When is cosine equal to -1/2? Say it again. Good. We have to force ourselves to look in the first and second quadrant, right? 2π/3. When is tangent equal to -√3, or in other words, -√3/1? Good. -√3/1, y/x, sine over cosine. Make an adjustment. And fourth quadrant, we have to call it -π/3. Yes.
So the only time we're going to make an adjustment in that chart is if we find the value of 1.
That's right. And it's only going to matter fourth quadrant for sine and tangent. For cosine, just use first and second quadrant. Okay. Hi, what do you guys think? Okay. All right, next page. Your classwork is just 1 through 12. And give you guys, hopefully, you can finish this in the next 10 minutes, and I'll go over them, go through any questions that you have, and I'll come around to check you off. Should be quick and easy today. There's a tricky one here, though. I'll point that out. Number 8. Why is that tricky? Basically saying, when is sine equal to 3? What do you know about the sine graph? Yeah, it only hovers between -1 and 1, so it's never going to reach a y value of 3, so it's undefined. That's a... Your sine graph is always going to just hover. Just never has a chance to reach up to that point. Okay. I want to come around and just check how you guys are doing, and then I'll go over the answers, and then we'll be done.
For some reason, I was and then for
Sine is first and second quadrant. Sine was the fourth quadrant. If you're in the fourth quadrant, five is the fourth quadrant. Yes. All right. Other than that, everything's going to line up. So 3.2, that's you want the right place. Whenever we're dealing with the fourth quadrant,
Guys, let me show the answers and see if you guys have any questions, and I'll go over any of these that that you want me to clarify. So I think the biggest thing I want to make sure that we understand is if you're pulling from the fourth quadrant, you do have to make an adjustment, right? Normally, you probably want to say 3 pi over 2, or 5 pi over 3, or 7 pi over 4, or 11 pi over 6. But if you're using sine or tangent in the fourth quadrant, you got to make an adjustment. So 3 pi over 2 is now negative pi over 2. 5 pi over 3 is now negative pi over 3. 7 pi over 4 is negative pi over 4. 11 pi over 6 is negative pi over 6. You basically are just rewriting your first quadrant values with negative with negatives, right?
Can you explain number 7?
Sure. Number 7 says, when is arc tangent equal to 0? So basically saying, when is tangent equal to 0? Okay, so tangent is first and fourth quadrant. Tangent is y over x, sine over cosine 0. The only place I'm going to get 0 over 1 is here. 0 over 1 is 0. Because I know that 1 over 0 and negative 1 over 0 is undefined, so the only 0 I'm getting is 0 over 1.
Because it's fourth quadrant.
Well,
What stops you from doing 2 pi?
yeah, so we're not doing 2 pi because we want something that will extend from negative pi over 2 to pi over 2. So along the way, it's going to be 0 to pi over 2. Right. Yeah, so for 0, we're just going to just use 0. Good. Any other questions?
Oh, number 2 is going to be negative.
No, because cosine is first and second quadrant. So, right. So second quadrant, we are good. We don't have to worry about any negatives. Only fourth quadrant. Yeah, the only time you're going to get a negative for your principal value is potentially with sine and tangent. Yeah, we don't use fourth quadrant for cosine because first and fourth are both positive, so we want negative, so we use first and second. Okay. Any questions? All right, let me check you guys off, and that's all I have for today. You're looking at sine, you know, oh, sorry. This is just a way of saying fourth quadrant, but adjusting for the fact that we are starting on the negative side and going on the positive side. So just let me know that. Like if we're looking at the visual graph, instead of something that is over here, we're looking at something that's so the fourth quadrant leading up to it keeps repeating itself, like we're forcing it to be over here because we want our graph to just show this region because we don't want any so that you just have to know that when you're in the fourth quadrant,
That's the thing about 3, 5, or 2. Yes, it's C 5, 5, or 3. You gotta do this. Yeah. But really, it's just repeating what the first quadrant is, right? 5 or 6 is closest to the x-axis. 5 or 4 is there together. Exactly. And here, this is, you know that 5 or 3 is the closest to the x-axis. So it's this. There is cosine equals to negative. Now remember with cosine, if only if you're looking at it, looks like sine and tangent.
So it's only in the fourth.
That's right. They have to change it. It's only for sine.